what is it like inside a black hole? So, what we understand about black holes comes from the theory of general relativity. And this theory says that when you take a mass, any mass, and you compress it further and further, the effect it has on space time becomes more and more acute. So if space time is a sheet and a ball of mass produces this distortion in the field in the sheet, then the more condensed a mass is, the more dense a mass is, the greater it's going to stretch the fabric of space time. And if you compress a mass sufficiently enough so that it becomes equal to or less than its so-called Schwarzschild radius, then it basically produces an infinite amount of warping of this fabric of space-time, and that's what we call a black hole. So the equations of general relativity, Einstein's equations, they produce what's called a singularity, which means it's division by zero. It doesn't mean that there's an actual infinite density in there. It actually means that our theory isn't able to handle that specific condition. It means our theory isn't accurate enough. It shows up the limitations of the theory of general relativity. It tells you that we need to be able to formulate a better theory. We need to formulate a better theory, one that takes into account the quantum domain of the universe. So we basically need to find a way to reconcile quantum mechanics, quantum field theory, and general relativity, which is something we haven't achieved thus far. Because if you try to quantize gravity, it doesn't work. It blows up. It breaks down. You cannot have space. I mean, you cannot have quantum field theory doesn't work in curved space time, etc. So these are the problems that theoretical physicists are grappling with. So essentially, what I'm trying to say in so many words is we don't know what's inside a black hole. A black hole is something it's a region of space-time that's cut off completely from outside orbit, from outside observers. The boundary is what's called the event horizon, and there is no way of knowing what's inside because everything that goes inside never comes out. Except in the form of thermal radiation, the so-called Hawking radiation, which doesn't tell you anything about what's really inside the black hole. So what's inside a black hole, we don't know. There could be, well, there are speculations. A black hole could possibly be a bag of single-dimensional strings, perhaps. It could be something that contains just radiation, photons. Maybe it contains just pure mass. That's another speculation or possibility. Some people say that a supermassive black hole or any black hole could essentially be a pathway to a different universe. It could end on the other side in a white hole and bring you out in a different universe in which time flows backwards. And then it's also a possibility that supermassive black holes may contain entire universes inside them. So these are speculations, but we have no way of knowing. First of all, because we don't have access to a black hole on which we can do experiments. Because you know what black holes do, they suck everything in. So we don't have access to a black hole in a laboratory. We don't have any black hole that anywhere nearby us that we can observe and get a better idea of. And the theoretical framework that we have isn't able to explain or answer these questions of what is the internal structure of a black hole. We know that black holes have mass, they have charge, they have angular momentum, and basically these are the three things that characterize the properties of a black hole. We don't know much beyond that. So there is a great deal of research happening into this matter. But as of today, this is another example of the limitations of our understanding of nature. We don't know what is the internal structure of a black hole. We don't know what's inside. We don't know what's beyond. So it's a great question, and these are the questions that drive physics forward.